Okay, so in this step we are going to set up the physics. Expand the physics, double click the models. In time, let's select implicit, unsteady, liquid, coupled flow, constant density, turbulence, K epsilon turbulence model. So that's all we need in this tutorial. Right, and then also expand tool, find motions, expand motions, and right click the motion and select new, rotational. That's how we create a rotational motion to the object. In the value, property values, x direction is our rotational axis, so let's define that. And also the rotational speed, select RPM, and let's define the RPM to 120 RPM. So that's all we have right now, and we could assign this motion to our object. Actually, I just find seems the rotational direction is reverse, so let's just go back to the rotational speed and change that to negative 120 RPM. Alright, so everything is good. Let's go to cylinder number 2, go to physics value. There's a motion specification. By default it is stationary. Let's change to rotation. This is the rotation motion we just created. Then the rotation motion will only operate to cylinder number 2. Cylinder number 1 is still stationary. Okay, and also because the wall, we need the wall to be stationary, so let's go to the wall, cylinder wall here, and in the physics condition there will be tangential velocity specification. Let's change that to rotational rate, and then in physics value the wall rotation speed will appear. Let's change the constant value to 120 RPM because our rotational speed is negative 120 RPM. So let's change that to 120 RPM. This 120 RPM on the wall will counteract the rotation of this region here. So that's about the setup. And also let's set up the initial conditions. The velocity right here, I would like to set it to 0.5 meter. And also in the inlet, let's also set up the velocity at the inlet to be equal to 0.5 meter per second. So that's about the setting for physics boundaries.